So listen to this. This is the first question in limits that I'm dealing with, and I have four options A, B, C, D. I have to choose. They've given that the limit exists for this, okay? And you know sine theta by theta, limit theta tends to 0 is 1. So let's take x to the power A into sine B to the power x by x to the power B by sine x to the power C by x to the power C. So that I can't just divide it, I also have to multiply and divide. So then therefore multiply and divide. Okay, and so this will become 1, this will become 1, it will become x to the power A plus B minus C, all the exponents combined together. And this is what I get. And they have said that the limit definitely exists. So x cannot be 0 because it has to be some number. And it has to be some number and it has to be having a non-zero value. So let me assume that the power can be 0. The only way I can do this sum, the power can be 0. So a plus b minus c can be 0 because x to the power 0 can be 1. So on that assumption I get a plus b is equal to c, and that is the right answer. So this is one question. So second question is this, where f of x is equal to cos of greatest integer function of x when x is greater than or equal to 0, and mod x plus a when x is less than 0. You have to find the value of a. The four options have been given. So let's do the left hand limit. Limit of f of x extends to 0 from the left. The formula for it is cos of greatest integer. Okay, the formula is for less than x, it's this one, which is mod x plus a. And I know direct substitution because it's not a 0 by 0 format, so answer itself is a. And let's do the right hand limit. X tends to 0 from the right. The formula is cos of greatest integer function of x. And you know you're going to substitute greatest integer function of cos of greatest integer function of 0. And a cos 0 itself is just, this itself is cos 0. And cos 0 itself is 1. And therefore a is equal to 1. Therefore option number D is the right answer. Okay, so let's understand this question. There are four options A, B, C, D. All options have been marked on the right. You have to choose the right answer. This is a format where you have to see that m is tending to infinity, where normally x will tend to 0 or x will tend to infinity, where x will be a variable. So therefore here instead of x it is m, so m is the variable. And you have m which is a variable, which means this x can be taken as a constant. Which means this x can be treated as a constant, correct? Yeah, so then therefore this is like a function to the power function. So whenever you have a function to the power function format, you know you should write it as, this is the format you have to follow. You have to make sure that you're writing it as e to the power. So you have to convert it as limit of, you write it as e to the power. Whenever you have function to the power function, simply write it as e to the power limit of m tends to infinity. So bring the m forward, cos x by m minus 1. This whatever is in the power, the variable m can come forward. The cos x by m minus 1. Just follow this format whenever m is tending to infinity. Just like sin theta by theta, tan theta by theta, you have all these properties through which you can do the sum. So m into cos x by m minus 1. Bring it forward and write that cos minus 1. Okay, so then once you do that, e to the power limit of m tends to infinity, it is 1 minus cos theta. So you can take in the format, if you take minus m out, it will be 1 minus cos x by m. And a 1 minus cos theta is 2 sin square theta by 2. So minus m into 2 sin square 2x by m. Okay, so then there is an e to the power. This whole thing is happening in the as e to the power. Okay, let's solve the power part. And can you see if m is tending to infinity, this is 1 by m will obviously tend to 0. So therefore this entire answer would become 0. So it will become e to the power 0, and therefore the answer itself is 1. So A is the right answer. So remember, it's function to the power function. This is the format we're going to write. Whatever is the power has to be brought forward. E to the power m, the cos of that value minus 1. The function minus 1. So the next question is this. It's quite a simple question. And as you can see, which way limit x is tending to 1. the denominator is becoming 0 and the numerator is also 0 by 0 format. So whenever you have 0 by 0 format, you can directly do L'Hopital rule, because this is a very direct function. So minus 2x by a cos 2 pi x into 2 pi, where 2 and 2 get cancelled, you get minus x by pi into cos 2 pi x. Limit x tends to 1. In the place of x, just put 1. So it's minus 1 by pi into cos 2 pi, and cos 2 pi is cos 0, which is 1. So minus 1 by pi is your right answer. So then therefore the option number B is the right answer. So this is another question. You have to find the limit when x is tending to infinity. Okay, so then let's just differentiate as numerator and denominator. So 1 by x square plus e to the power x into 2x plus e to the power x is the L'Hopital rule I'm trying to apply. 1 by x to the power 4 plus e to the power 2x into 4x square plus 2 into e to the power 2x. So then from this is about limit x is tending to infinity. So from this it's x e to the power x. So then make sure that you're going to take this to the numerator. What is the denominator? X to the power 4 plus e to the power 2x, the numerator, with the 2x plus e to the power x by x square plus e to the power x into 4x square plus 2 into e to the power 2x. So in this format, when limit x tends to infinity, you have to see what, when you multiply, which gets you the highest power. Okay, so then can you see that x to the power 5 will be there. X to the power 5 is the highest power here, whose coefficient is just 2. And when you multiply this, you get x to the power 4, which will be the highest coefficient, and whose coefficient is 4. X to the power. So take the highest coefficients and just divide them. This is the rule that we adopt, whichever has got the highest coefficient, because whenever you see x is tending to infinity, you can remember this: the higher power terms will always dominate the lower power terms. Therefore, in the numerator, what is the highest power, you multiply and see. Denominator, what is the highest power, you multiply and see. And their coefficients is what you need to take, because they're only dominant. You can ignore the rest of it, and that is the way, whenever x is tending to infinity, we are using this rule to solve it. Okay. So here is the next question. You see that there is a floral bracket here. Such is denoted by fractional part. What is the meaning of fractional part? Let me tell you. The fractional part is x minus greatest integer function of x. That is what a fractional part means. So in here you have to substitute that. Okay. So then let's study about the left hand limit. For left hand limit, you're going to do limit of wherever x is, you're going to put minus 1 minus h. Wherever x is, you're going to put minus 1 minus h, because approaching from the left. And so writing it in the formula. And the function by 1 by root of mod of minus 1 minus h minus, there is a floral bracket, which means it's x minus mod x. That's what it means. So let's take it as x minus greatest integer function of x. That's what the floral bracket mean. And so then so minus, let's substitute for this. You know, it's this is nothing but, and this is fractional part of x, but this is fractional part of minus x, right? So here it will become minus x minus of minus x. So this is becoming like that. Okay, wherever x is, you have to insert a minus sign. So this is what it is, and this simply signifies greatest integer function. So I'm substituting this here, minus x minus of minus greatest integer function of x. So now you have to substitute minus x. You have to find what this is. You know, x is equal to minus 1 minus h. So minus x will be 1 plus h. So you're going to substitute in the place of this, this is the value, and and instead of minus x you have to write. So basically this is what is going to come here in replacing the floral bracket, and when you write that, it's root of minus 1 minus h minus 1 plus h, that is what is minus x minus greatest integer function of minus x, which is 1 plus h, and this whole thing is going to be within one bracket like this. Okay, and then therefore now limit h will tend to 0. Because of that, the whole thing is going to, h is going to tend to 0. And if you simplify this, okay, 1 by h is going to become 0. A mod of minus 1 is just 1. And on simplifying this is greatest integer function of 1 plus x, and a greatest integer function of a 1 plus will be just 1 plus h will be just 1. So then therefore, if this is an ordinary function, so h is 0, it will get to 1, and minus this is 1 plus h, which is again 1. So therefore I'm getting a 1 by 1, this will become 0, 1 by 1, so answer is 1. So B is the right answer. So from this we understand what is the meaning of fractional part. A fractional part function is one where they'll represent by a floral bracket, which is x minus greatest integer function of x. But since it's fractional part of x is x minus greatest integer function, fractional part of minus x, therefore will be minus x minus of minus greatest integer function of x. And so then from here you should substitute that in here and find out, and then resubstitute. Such a wonderful sum. But we have only done the left hand limit. Let's do the right hand limit and see. So it's limit of f of x tending to minus 1 from the right, which means it's minus x will become minus 1 plus h. X will become minus 1 plus h. And what will minus x will become 1 minus h. Okay, just remember that we may have to substitute that. And so then when you do that, here when you substitute, it will be 1 by root of mod x, and the mod x can be written as mod x. Yeah, mod x can be written as what is x? It's minus 1 plus h. Okay, the mod part is over. Minus the fractional part of minus x. The fractional part itself is x minus mod x minus greatest integer function of x, and I have to fill in the value. For what is x? X itself is minus x, minus of minus x. So substituting this value in here, it will become minus x is 1 minus h. Okay, and the greatest integer function of minus greatest integer function of, so let this be an ordinary bracket, minus x again is 1 minus h, and close it. Now limit h tends to 0. So 1 by this is getting cancelled, and h is also becoming 0, so this is becoming 0. What about what is in bracket? It's 1 minus h, and what is 1 minus h will be less than 1. 1 minus h, which means it's less than 1, and so then the answer for that will be 0. So this will be minus 1 minus 0. So it will be 1 by root of minus 1. And can you see we're getting root of a complex number, and that is its left limit is 1. So then actually 1 is not the right answer. Therefore 1 is not the right answer. It gets undefined. Left hand limit is not the same as left hand limit is not equal to right hand limit. So therefore limit does not exist is the right answer. I just tried only for the left side. You also have to try for the right side. So I hope you understood what is a fractional part. How do you write it for minus x? How do you define x, and how do you write for the left hand limit minus x, and for the right hand limit minus x? Hope you understood that part. It's very